Hello my dears, how are you all? So it's been a very long time, I know. Why? Because in the last lecture a UJT relaxation oscillator and UJT, working of UJT and all, views are very less compared to the previous video. So I concluded one thing, that what? You are not at all followed, right? You are not at all speed in the same speed as that of what in speed, or what speed in which I am taking class, right? That means you are not at all completely followed, right? I'm too fast, I know. That's why I slow down my speed. That's why for 4 to 5 days or 6 days I didn't put any class. But I hope you already know, you covered a lot, so that we will be in same phase, okay, together now onwards. So today we are going to discuss a very important section as far as the KCB sub-engineer syllabus, for assistant professor or AE syllabus. Everywhere you can see this topic, field effect transistor, my dears, field effect transistor. So what is this field effect transistor means? Why the name field effect transistor, I will tell you when we are dealing the working, and we are going to the working of that transistor, that means field effect transistor. You will definitely get the idea why the name field effect transistor, okay? So as a general, my dear, field effect transistor is nothing but it is a special type of transistor in which the input impedance is very high compared to the BJT. Compared to the BJT, the input impedance or the input resistance offered by the transistor is very high. Why, or what is the advantage of the input impedance is so high with compared to BJT in FET is that whenever the input impedance is very high means it doesn't allow all of the signal from the input side. It doesn't allow all of the signal. It reduces the intensity of the signal. That means noise signals doesn't include in our system, not that much. I mean, noise signal will not be come into the system because of the high input impedance offered by the field effect transistor. So that is the main advantage of field effect transistor. And one more very important advantage, or one more point in field effect transistor is that FETs are unipolar devices. See, BJT means bipolar junction transistor. Why the name bipolar junction transistor? There the total conduction is by both the electrons as well as the hole. Both the electrons as well as the hole. The total collector current is actually the sum of the current by the electrons plus the current by the hole. That means the current due to the majority plus due to the current due to the minority carriers are the total current. That is why the name bipolar. Both the electrons and holes take parts in the conduction. But in the case of FET, both in Jfet as well as in MOSFET, the conduction is either through electrons or through holes, depending upon what channel we are making. A channel of electrons means only electrons take part in conduction. A channel of holes means only holes will take part in the conduction. So that is the two difference between FET and BJT. One, the input impedance is very high. The advantage is that noise signals will not be interfere into the system. Into the system means into the circuitry where we are using FET, because it offer a very high input impedance. Noises will normally encountered into the system when the input impedance is very low. The input impedance very low means that the system will allow everything into the system. Input impedance is very high means it is like a wall. No one can easily enter into the wall, right? Because of that high input impedance. So that is the main advantage of what is our FET compared to the BJT. So FETs are again classified into Jfet and MOSFET. Jfet is nothing but, my dear, junction field effect transistor, and a MOSFET is nothing but metal oxide semiconductor field effect transistor. So towards our classes, I mean, now we are going to discuss everything in detail, very detail. So the continuing classes will cover everything in very detail according to the examination point of view. Not much beyond, I mean not much more, because as far as the university exam concerned, you have to know very clearly, very important, I mean some of the factors, some problems regarding the Jfet and MOSFET, everything you have to note. But in the case of examination point of view, we need very important terms, we need some important parameters, some important concept only, that only we need. So according to that I am going to take, okay. So first of all we have to discuss about junction field effect transistor. So while we are dealing or while we are moving, definitely you will understand why the name junction field effect transistor. So until then, please make a surprise, okay. Please be surprised. So what is the meaning of junction field effect transistor? I will explain that also. So this is the structure, my dear. This is the internal structure of a junction field effect transistor. That means it is a three-terminal device, right? It contains source, it have a drain, it have a gate. It is similar to emitter, base and collector. Emitter, base and collector in a BJT. And here this end region, this area is very high. That means compared to the UJT what we studied, UJT, this P region was near to the end region. The PG region was near to the end region, am I right? But it is exactly in midway of N channel, so that equal portion will be upper and equal portion will be the lower area. And this N region is called the channel, and according to this channel, the naming of the Jfet is done. Suppose this channel is contain N, that is nothing but the free electrons, then this is called the N channel Jfet. And this is the symbol of the Jfet. The symbol is very, very important. For some beginner based examination or even AE based examinations, even they directly ask for the symbol, not the very big concept, not the very big equation and all. They simply asked for what is the symbol. What is the symbol? So symbol is very, very symbol is very, very important, my dears. And the difference between N channel and P channel Jfet is nothing but, my dear, this is the N channel Jfet, okay, right. This is the N channel Jfet, which means the channel, this is the channel, my dear, this is the channel. This is the channel. And suppose this place is replaced with P and this gate is replaced with N and N here, then it is called the P channel MOSFET. And the difference in symbol is only that the arrow will be away from the circle, that's all. That means this will be the symbol, okay. This is the N channel now, so only difference in the P channel. This will be the P channel. P channel Jfet. This is source and this is drain and this is, okay. That is the only difference between N channel and P channel Jfet. And these two gates, my dears, these two gates are what? Internally connected. But in the circuitry that we are going to discuss, whenever we are using Jfet, in all that circuit diagrams, in all those circuit diagrams, we are not going to mention this internal connection. We are simply take a gate terminal as one connection. You should understand that. You should understand that these two gates are internally connected. That you should feed into your mind. The two gates are internally connected. That you should keep in your mind. Okay. But we are just mentioning only one terminal in the further sessions, okay. And This is p material and this is p material, and this is nothing but n material. That is the only difference compared to BJT. There you have junctions, but here another type of junction, that I will tell you. So this is nothing but the overall structure of the Jfet, and now we are going to discuss the working. So before I am going to discuss the working, we have to properly bias the Jfet. So I am utilizing the same figure for the biasing purpose also, so that I will consume less time, right? I will consume less time. This is VDS and this is VGS. This is source and this is drain. That's all. And this is ID. And this is ID. Listen, my dear. Let's move into the working of Jfet. Let's move into the working of Jfet. This is S. Okay. Just redraw a figure in your notebook. Okay. Don't use my method. For not consuming so much time, I simply rub in the original figure and rearrange. Okay. In the notebook, you have to redraw the figure, you have to pause the video, you have to redraw the figure. Otherwise, you will get confused. Okay, my dear. So let's move into the working. So this is the structure. The source to drain region is always what? A reverse bias condition regarding this drain. So regarding this drain, it should be always a reverse biased, not according to the source. Source you forget. Regarding the drain, it is always to be reverse biased. One thing. The gate to source is always again reverse biased. Both the sessions will be always in reverse biased condition. That is the important. Compared to the BJT, in the input side of BJT is always forward biased, right? Emitter to base junction always forward biased. Collector to base junction reverse biased. Correct? So here in Jfet, gate to source is always reverse biased. Always reverse biased. There is a switch S. So initially the switch is in open position, so that this VGF will not be here in the gate. Initially S will be open, so that there will not be any connection to gate and source. That means gate to source voltage is simply 0 volt. Simple. Gate to source voltage is simply 0 volt initially. Okay. Initially 0 volt. So what happened? See, my dear, if I write everything in the board, it will take a very long time, and it's really boring, right? So much writings will be there. So it is better to note in your own words in your notebook. That's it. If you feel I'm very speed, you just pause the video. You just slow down you can adjust the speed of the video in the YouTube setting, 0.5x or something like that. You can put into that and you can note down everything. If you feel I'm very speed, okay. Listen. So at VGS equal to 0 means there will not be any influence of this VGS on P. That P will be simply like what they constructed. Now listen to me. This region is positive with respect to this region. So what happened? Electrons will rush into this P, because of higher the voltage here. Here in N channel, enormous amount of free electrons are there. That is why the name N channel. Electrons are the majority carriers there. So if I connected a positive polarity here, the electrons will be very happy, so that it will be attracted. He can go somewhere. he will be very happy. So the electron will be moved towards this positive polarity, and it will recombine the holes in the positive side of the battery. Is it clear, my dears? Is it clear? So what happened? There will be a flow of current in the opposite direction, because the current will be always flowing from positive to negative. You all know this. Current will be always flowing from positive to negative. You all know this. Or opposite to the direction of the electrons flow. So this is the electrons flow, this is the current flow. So external to the circuit, my dears, external to the circuit is very important. The word external. External to the circuit, there is always a flow of current from source to drain. There is always a flow of current from source to drain in the external circuit. External circuit. Is it clear now? The switch is open. The switch is open. Next, what happened? I simply on my switch. Suppose I turned on my switch. What happened? This VGS will be included in the circuitry. This VGS will be included in the circuitry. Am I right? This VGS will be included in the circuitry. And the beauty of the VGS is that this VGS is negative with respect to this P, which will make this P reverse biased. Which will make this P what, my dear? Reverse biased. Because N to P. What happened then? What happened then? What happened then? The thing will be nothing but there will be an increased depletion layer. There will be an increased depletion layer. That means, my dear, this N it's combined with some of the holes in the P region. Some of the holes in the P region. Okay, that means electron will be moving from here to here. It will combine with the hole. It will combine with the hole. But if you consider this P and N region, if you consider this P and N region, this P got negative polarity. This P got negative polarity. N got already opposite polarity. So this PN junction, my dear, will be in reverse biased condition. This PN junction will be in a reverse biased condition. So that what happened? The reverse biased will expand in such a way that it is toward into. That means it will move in this way. Not towards P, but towards N, the depletion layer will expand. Towards N, the depletion layer will expand. What happened, my dear? Compared to the previous case, now the width of the channel got reduced. Now the width, initially it was there. Initially, here and here was the channel gate, the gate width. But now, this and this will be the gate width. If I am again increasing my VGS, it will again like this. So again I increased my VGS, it will be again like this. So again this will be the channel width. Again this will be the channel width. So the conclusion is simply this. Whenever we are increasing the value of VGS, the channel width got reduced. If the channel width got reduced, the current ID will be reduced. The current ID will be reduced. Is it clear? So maximum current will be flowing when VGS equal to 0. Minimum current will be flowing when VGS equal to maximum value. Maximum value. Maximum value. Is it clear, my dear? Is it clear? So that is simply the working of the Jfet. That is simply the working of the Jfet. So come to the point, junction field effect transistor. Why the name? I already told you, it's a surprise. It's a surprise. So the voltage across the gate and source. Okay, that is nothing but the voltage across the junctions, this gate and source junction, will affect the drain current. So, or the field across these and these will affect the drain current. That is why the name junction field effect transistor. The field across these two will affect the drain current. That is why the name junction field effect transistor. Junction field effect transistor. Okay, that is why the name, my dear, junction field effect transistor. And again we are increasing the VGS. This will again come into contact, and finally this two depletion layer will touch, and at that point there will not be any channel for the flow of electrons. The current ID will completely stop there. So simply by adjusting the depletion layer, by adjusting the value of VGS, by increasing the reverse polarity of VGS, we can control the current ID. So that is why it is called the junction field effect transistor. That's why it's called the junction field effect transistor. Okay. Is it clear, my dears? Is it clear? So compared to BJT, so what are the advantages of Jfet? High input impedance, less noise, and unijunction. What do you mean unipolar? FET are unipolar, either by electrons or by hole. Now it is simply by electrons. So only by electrons or by hole. In P channel, it is same reverse thing have happened. By holes, the conduction will take place. In N channel, the electrons will take part in the conduction. So this is a unipolar transistor, but BJT is nothing but a bipolar junction transistor. Is it clear? My dears? So that all about the Jfet and its working and its symbol.